Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P086B, signifies that the neutral position sensor A output voltage is outside the specified range set by the vehicle's manufacturer. This diagnostic code is related to the operation of the neutral position sensor, which plays a critical role in the functioning of the vehicle's transmission system. This sensor is responsible for providing the powertrain control module, PCM, with essential information regarding the transmission's neutral state, determining if the vehicle is in gear or neutral. Located typically near the transmission housing, the neutral position sensor helps ensure safe and efficient gear transitions. When the PCM detects that the sensor's output voltage is either less than 0.66 volts or greater than 3.34 volts, it triggers this code, indicating a malfunction that needs troubleshooting. This malfunction could adversely affect vehicle operation, leading to unintended behaviors in gear selection. The DTC P086B indicates an issue with the neutral position sensor A, a crucial component in the vehicle's transmission system. This sensor communicates with the powertrain control module, PCM, which is responsible for regulating engine and transmission functions based on input signals. The neutral position sensor is typically located on the transmission housing, allowing it to accurately gauge the position of the transmission gear. By sending the correct voltage signal to the PCM, the sensor ensures that the transmission operates smoothly and efficiently. If the output voltage falls below 0.66 volts or above 3.34 volts, it signifies an anomaly requiring immediate attention. Understanding the role of these components is vital for effective troubleshooting, as they are interconnected in the vehicle's operation. Ignoring this code can lead to serious transmission issues, ultimately affecting vehicle safety and performance. Several potential causes can lead to the triggering of DTC P086B. Firstly, a faulty neutral position sensor is a primary suspect, as it may not produce the correct voltage range, indicating the vehicle's gear status. Secondly, an open circuit can occur if there is a break in the wiring between the sensor and the PCM, preventing proper signal transmission. This can adversely affect the functionality of the entire transmission system. Thirdly, a short circuit in the wiring can cause excessive voltage or prevent the sensor from sending any signal at all, driving the PCM to store this DTC. Each of these issues might stem from wear and tear, environmental factors, or manufacturing defects. Diagnosing the exact cause requires systematic inspection and testing of the sensor and the associated wiring harness. When DTC P086B is present, various symptoms may manifest, indicating a malfunctioning neutral position sensor or associated circuits. One of the most critical symptoms is improper transmission shifting behavior. Drivers may experience harsh or unintended shifts, leading to confusion when engaging the transmission. Additionally, a check engine light will typically illuminate on the dashboard, alerting the driver to an issue within the vehicle's electronic systems. More severe cases may involve an unresponsive gear selection, where the vehicle may remain stuck in a single gear or fail to engage the appropriate gear in response to driver input. It is important to take note of these symptoms, as they provide insight into the status of the neutral position sensor and the overall health of the transmission system. Ignoring these signs could lead to further complications and potentially hazardous driving conditions. The first troubleshooting step for DTC P086B begins with verifying the vehicle's operational mode. Turn the vehicle's ignition to the on position. This allows for the vehicle systems to activate and prepares the necessary diagnostic tools for the inspection. Next, the Honda Diagnostic System HDS tool should be used to check the value of the Neutral Position Sensor 1, NPS-1. For a correctly functioning system, the HDS reading should fall within the specified range of neither less than 0.66 volts, nor more than 3.34 volts. If the reading exceeds these values, it confirms the presence of a malfunction, necessitating further inspection of the sensor and its connections. Accurate readings from the HDS are crucial in guiding the technician toward the next steps necessary for resolving the issue and avoiding unnecessary replacements. The second troubleshooting step focuses on further confirming the functionality of the neutral position sensor. This involves once again having the neutral position sensor 4P connector disconnected from the sensor itself. With the vehicle in the on mode, the HDS should be monitored for the reading of the neutral position sensor 1, NPS-1. If the sensor is functioning correctly, its output value should read 0 volts, indicating that the sensor is active but not detecting any position change. If the reading deviates from this expected output, this suggests a failure in the neutral position sensor itself, further necessitating either a recalibration or replacement based on diagnostic guidelines. Thorough examination during this step is critical, as incorrect readings could lead to misdiagnoses down the line. In the third step of troubleshooting for DTC P086B, you will take further diagnostic actions by jumping specific terminals in the neutral position sensor 4P connector. Disconnect the connector, then use a jumper wire to connect terminals number 1 and number 3. Once this connection is established, turn the vehicle's ignition to the on position again. The HDS should now read a value of approximately 5.0 volts. If this reading is observed, the neutral position sensor is indicated to be faulty, as it is not providing the expected output signal and supports diagnosis from the previous steps. Conversely, if the reading is abnormal, indicating either less than or more than 5.0 volts, the issue may lie within the wiring or the PCM, suggesting further inspection is required. Each procedural step builds upon the last, crucial for isolating the exact fault. The fourth troubleshooting step involves inspecting the circuits associated with the neutral position sensor. Begin with the neutral position sensor 4P connector still disconnected, followed by disconnecting the PCM connector as well. Perform an inspection on the VCC1 or voltage supply circuit. If this circuit shows an open condition or is faulty, a resistance reading should ideally be less than 1 ohm. Subsequently, the NSS1 or signal circuit should also exhibit the same resistance level, confirming there's no break in the connection. Lastly, check the SG1 ground circuit for similar readings. Following this methodical approach helps identify whether there are any issues in the wiring that could be causing the DTC. Should any abnormalities arise in these readings, further circuit repairs will be critical to ensure the neutral position sensor can relay the necessary information to the PCM effectively. The final step in troubleshooting DTC P086B is centered around inspecting the powertrain control module PCM itself. If all previous inspections returned normal conditions, it becomes necessary to isolate the PCM as a potential fault. This involves examining the PCM for any signs of damage, corrosion, or connection issues. In the absence of faults in the neutral position sensor or its associated wiring, the likelihood of PCM failure increases. Performing diagnostic tests on the PCM may reveal internal failures, which would necessitate replacement. As the PCM serves as the core processing unit for engine and transmission control, any failure here can lead to extensive transmission problems and thus requires careful attention. Proper verification in this step is essential, as it confirms whether the previous steps were effectively isolating the right issue, ensuring the reliability and functionality of the vehicle systems. After completing the troubleshooting and addressing the identified issues, it is imperative to perform final verification of repairs made in relation to DTC P086B. Begin by ensuring that all components associated with the neutral position sensor and the PCM are functioning correctly and free of issues. This includes rechecking the voltage output of the neutral position sensor to confirm it lies within the specified range. Following this, clear the DTC using the HDS diagnostic tool. It is crucial to conduct a road test afterward to monitor the vehicle's performance under various conditions. Observing the vehicle in real-world scenarios helps ensure that no symptoms of the original issue reoccur, providing confidence that repairs were effective. Thorough final verification fortifies the reliability of the repairs executed and enhances overall vehicle performance. Preventive maintenance plays a vital role in ensuring that DTC P086B does not recur and the vehicle operates smoothly. Regular checks of the neutral position sensor are recommended to detect any abnormal behavior before it leads to serious issues. Technicians should inspect the wiring and connectors associated with the sensor for signs of wear, fraying, or corrosion. Keeping these connections clean and properly maintained can greatly reduce the likelihood of electrical faults occurring. Additionally, ensuring that the PCM software is up to date can help in the early detection of potential issues. Creating a consistent maintenance schedule promoting these practices allows for timely interventions, minimizing the risk of unexpected repairs and enhancing the overall lifespan of the vehicle components. In conclusion, understanding DTC P086B revolves around the neutral position sensor A and its interaction with the powertrain control module, PCM. Identification of key components such as the sensor, wiring, and the PCM itself is crucial for effective troubleshooting. Employing a systematic approach in diagnosing and addressing the issues ensures that each potential cause is explored thoroughly. Careful final verification of repairs made solidifies the restoration of normal functionality to the vehicle's transmission systems. Additionally, implementing preventive maintenance practices can significantly reduce the risk of future occurrences of this DTC, thereby extending the longevity of the components involved. This comprehensive understanding highlights the importance of diligence in both diagnostic processes and routine maintenance for optimal vehicle performance. Please like and subscribe to the channel. See you next time.